Assalamualaikum to Dr. Muhammad Asri and Dr. Siti Nohaida. My name is Harith bin Adnan and I will present my project Sarjana Muda 1, which is the development of a liquid fertilizer spray with angle control nozzle. They are supervised by Dr. Shamsu Anwar bin Shamsuddin. For the research background, the agriculture of durian in Malaysia grows exponentially as the demand from the local and international consumer is high. The application of drone has become the new alternative in agriculture as it can provide a lot of benefit to the farmer. The agriculture drone is an amended aerial vehicle used to help optimize agriculture operation, increase crop production, and monitor crop growth. Next, I will continue with the problem statement, objective, and the scope of this project. The problem statement of this project is the conventional method of agriculture used by the farmer consume a lot of time and require many workers. The agriculture drone is suggested to solve this problem and increase the efficiency of the farmer. As for the objective, the first one is to study the architecture design of the agriculture drone that are available in the market. Secondly, to customize the drone with suitable component and parts. Last, the last objective is to investigate the spraying mechanism and pattern suitable for durian planting. The project has three scopes. The first one is the specification of drone in market are compared to determine the compatibility to complete tasks. The second one is the research about working mechanism of the agriculture drone are compiled to provide guideline of the work process. The last scope is the component and parts are fabricated and added to the drone. Next, I will proceed with the literature review. There are four types of application of drone in durian agriculture. The first one is crop spraying. The drone can be used to apply fertilizer to the durian tree. Foliar fertilizer method can be used where the drone can apply diluted fertilizer directly to the leaf of the tree. Next is spot spraying. The drone can spray individual weed and also target insect infestation without needing to cover the entire crop. The third application is crop mapping and surveying. The farmer can use the drone that are equipped with camera and sensor to collect information regarding the overall crop and plant health, land distribution, current crop cycle, and detailed GPS map of the crop area. The last application is irrigation monitoring and management. The drone can be equipped with thermal camera to spot the temperature difference and pattern to measure the existence of the moisture. This will prevent moisture stress suffer by the plant. Now I will continue with the basic principle of the drone. The drone is made up of chassis, propeller, motor, flight controller, and battery. The chassis act as a skeleton of the drone that hold all the components and parts together. The motor will rotate the propeller to provide the required lift force to fly the drone. The flight controller contain onboard computer to control the rotation of the motor and the direction of the propeller. And the battery is used as a power supply for the drone. Okay, next, there are three parameters of the agriculture drone that are being considered. The first is the type of nozzle. The nozzle is selected based on the spraying application to increase the efficiency of the spray and prevent droplet drift. Next is the camera and sensor. The drone need to have the camera and sensor for visual evaluation and data collection of the crop. And lastly, the drone need to have enough lift force in order for the drone to fly when carrying heavy payload. The drone is estimated to be able to carry around 25 kilograms of total weight. Next, I will continue with the methodology of this project. This is the flowchart of my project. It starts with the literature review and the comparison drone in market. Then, product specification, conceptual design, screening and scoring were made to obtain the design of the drone. If the design satisfies the customer requirement, then I can proceed to the detail and fabrication. After that, the prototype of the drone is ready to be tested. I will proceed with the customer requirement. The first one is spraying function. The product need to be able to apply fertilizer, irrigation, pesticide, and herbicide to the crop. Second is portable design. The product need to be easy to be carried around anywhere. Next is affordable price. The price of the product should not too expensive for the consumer. As for the durability, the product should not break easily by random hazard. And lastly, reusable. The product need to have long lifetime and can be easily recharged for continuous uses. Next, I will go through the engineering characteristic. For the type of material, the material used for the drone will be mostly reinforced plastic that are durable, lightweight and flexible. Next is portable design. The drone can be disassembled to smaller component and can be reassembled back easily. For the operating system, the drone can be operated by using radio control transmitter as commanded by the user. Next is the reusable. The part of the drone can be easily exchanged if failure of the component occurs. And lastly, for functionality, the drone can have multiple attachments such as different type of spraying nozzle. This is the house of quality that compare the data that defining the relationship between the customer requirement and the engineering characteristic. This is the morphological chart that provide several options for such as the type of drone, the spray tank, the type of visual, the input power, and lastly, the type of nozzle. Now, I will continue with the concept design based on the morphological chart before. The table shows each of the selected option based on the criteria from the morphological chart to obtain the concept design A, concept design B, and concept design C. Next is a screening method. In order to choose the best concept design, we can compare the strength and the weakness of each concept by using this method. Concept design C received the highest score compared to the other concept design. The weighted decision matrix is also used to evaluate the concept design by ranking them with weighting factor and scoring the degree of which design meet the criterion. In this method, concept design C also received the highest score. Next is fabrication and testing. The design of the component from the drone will be done in SolidWorks software. Then the model will be realized using 3D printing technology. The components made are assembled correctly to be ready for testing session. The drone is then tested in the field, starting with the takeoff, navigating the terrain, carrying payload, and applying the fertilizer. The cost analysis of making the agriculture drone were made. The price was based on the biggest online e-commerce company, which is Alibaba.com. As a conclusion for this project, the study helped to obtain the correct feature for the drone. All the possible options have been evaluated to determine the best choice. With proper analysis, the flow of the project has become easier. The future plan of the project for the next semester, this project will focus on the fabrication of the component, prototype testing, and analysis of the result obtained. That's all from me. I would like to thank to Dr. Muhammad Asri and Dr. Siti Nuhaida for watching my videos.